Hey guys, in this video I'm going to share with you how 3D animations work and how you can implement them in your game engine. So let's begin right now. Hey, so most likely we haven't met, but I'm Hero Serrano and I developed a 3D game engine. And I'm here to share with you everything that I know about game engine development. And today I want to talk about how 3D animations work and what are the key concepts that you need to keep in mind in order to implement such feature in your game engines. So I'm going to start out by talking about the bind post matrix. This concept can be a little bit hard to understand in the beginning, but it is one of the key elements that you need to comprehend in order to implement an animation system in your game engine. To understand what a bind post matrix is, you need to learn some terminology used in computer graphics. Here I have the two main players that makes animations possible. I have the skeleton, which is basically a set of bones, and I also have what is known as the skin. It is basically the mesh of your character. And when we bind the skeleton with the skin of the character, what we create this relationship between the bones and the vertices of the mesh. And mathematically, this relationship is known as the bind post matrix. And what happens is that this matrix allows for the deformation of the skin whenever a bone is rotated. For example, let me show you that right now. I'm going to pick a bone and then I'm going to rotate that particular bone so you can see how the deformation of the skin happens. You see how the skin is being deformed at that point. If I select a different bone here, like the neck, and I rotate the neck, you will see how the skin is also deformed. And it would be better if I actually show you the whole texture. So here you see how that is being deformed, and all of this happens because of the bind post matrix. Now you may want to see how this really works mathematically, so let me share that with you so you have a better understanding of how that works. Alright, so the bind post matrix allows for each bone to go from its own local space to the local frame of the skin. All right, that is what the bind post matrix represents. Now, if you let T to represent the transformation from the local frame of the bone to the world space, then it turns out that the transformation for each vertex to go from the skin local frame to the world space is represented by this transformation T, which represents the transformation of the bone to go from its local frame to the world space, and the inverse of the bind post matrix, which allows each vertex to go from the skin local frame to the local frame of the bone. So whenever a bone is rotated, T also changes, and that allows for a deformation in the skin to occur. Alright, so the second key concept that you need to comprehend is known as vertex blending. Basically, whenever you bind the skin and the skeleton, a particular value is defined which states or determines how much influence a bone has on a particular vertex. And right here on Blender, I actually show you how much influence the bone has on the nearby vertices. Just so you know, whenever you see the color red, that means that that particular bone has the maximum influence on the vertices nearby, and when you see blue, it means that it has no influence at all. So in this case, the bone that I'm highlighting has total influence, 100% influence on the vertices right here at the bottom of the mesh. But it has no influence whatsoever on any other vertex. Now, if I select the second bone, the bone in the middle, you will see that that particular bone has a lot of influence on all of the vertices that are located in the middle of the mesh. And if I select the bone at the top, you will see the same idea. These vertices right here are influenced by this particular bone. Well, what does this mean? Well, what this means basically is that whenever we rotate a particular bone, the vertices with zero influence from that bone will not move at all. That bone will have no effect whatsoever on those particular vertices. Let me show you that. If I rotate this bone right here, you will see that only the vertices at the top are actually distorted or moved. The other vertices, they do not move, they stay stationary, as you can see that. However, I can easily change that influence. Now if I come here from Blender and I do the following, I'm going to select these bones and I'm going to assign a particular influence on that bone. So when I get out from here, you will get to see that now bone number 2 has total influence on not only on the top vertices but also on the vertices right below. So in this instance, if I were to rotate the bone, you will see that the bones that were in these locations will also be affected, and you will notice that right now you see how the vertices also are deformed by that bone. And that is the whole idea behind vertex weights. It is the value that represents how much influence a bone has on the nearby vertices. Now obviously we need to take into account the vertex weights in our final transformation. And what you basically do is you represent the transformation instead of a simple transformation as shown here. What you do is we use a linear combination of the transforms associated with each bone. And as you can see here, for each bone we also have the particular weight, the particular influence that bone has on the vertex. So we basically take the linear combination of all of these transforms, and that will give us the final transformation for that particular vertex. Alright, so now you know about bipost matrix and vertex blending. The third key concept that you need to comprehend is keyframes. And keyframes are basically a snapshot of the transformation of each bone in your skeleton in a particular timeline. For example, here I'm actually clicking on each keyframe, and you can see how as I select a keyframe, the transformation of each bone changes. Again, that's all what it is. It stores the transformation of each bone in a particular timeline. The fourth key concept that you need to understand is interpolation. Why? Well, because you do not want to send only the keyframes to the GPU. Why? Well, because if you do that, you are going to get a choppy animation. For example, if I simply select each keyframe here in my animation, you will see that the particular animation looks very choppy. What you want to do is you want to interpolate the data between each keyframe so that your animation looks more smoothly. The interpolation that I'm talking about is basically all of this data that you see here in between the keyframes. So if I were to play the whole animation, you will see that now the whole animation is more smoothly and you can actually make out what it represents. Now, one more thing to keep in mind when it comes to interpolation, you do not want to interpolate the data between the keyframes using matrices. You do not want to do that. You want to use quaternions. Now, I'm not going to go into that topic right now because that can easily take a whole video. But I will recommend you a really good book if you are interested in learning more about quaternions. It's this book called Quaternions for Computer Graphics by John Vance. It is one of the best books I've read on quaternions, and I read several. And this book, not only is it very, a short read, it is the most comprehensive book on quaternions. And I'm going to post a link in the description below so that way you can check it out. Now, the fifth concept that you need to understand is not really related to how animations work, but more of how you store the data representing your skeleton. And the ideal data structure that you want to use is known as a scene graph. A scene graph is a generic tree which has a fast traversal property, and in contrast to a binary tree, which can only have 2 children per node, a scene graph can have as many children per node as it desires. Now, because of this property, a scene graph is the ideal data structure that you want to use to represent the skeleton of a character for animations. Alright, so now that you have the bind post matrix, the vertex weight, the keyframe, and the scene graph, you are ready to recreate an animation on the screen. And it works like this. During an animation, you traverse the scene graph and you compute the final transformation for each bone by interpolating the data between the keyframes. This final transformation is sent to the GPU, and along with the vertex weights, the vertex shader computes the final transformation for each vertex, thus creating an animation on the screen. Alright guys, I hope this video was helpful. I hope that now you understand more about how animations in games work, and the 5 key concepts that you need to keep in mind whenever you are implementing an animation system in your game engine. And just to recap, they are the bind post matrix, the vertex weights, keyframes, interpolations, and scene graph. If you want to know more about game engine development, I'm going to post more videos here, so feel free to click on them. And if you haven't subscribed to my channel, please do so. This channel is all about game engine development, and that is all what I talk about here. I basically share with you everything that I know about game engine development. So please do subscribe, and also click on the notification icon button, so that way you get notified whenever I upload a new video. Alright guys, thank you so much for watching this video. I'll see you next time.